class. So today we will continue on chapter 1, which is enzyme. And last week we already learned about the definitions of enzyme, which is enzyme is the biological molecule that speed up chemical reaction by lowering the activation energy without being changed and stay unchanged at the end of the um, reactions. So you also learn about the characteristic in enzyme. For example, it have it has an active site. Okay, it works very efficient and etc. And also you learn about how the enzyme lowering the activation energy and also the enzyme specificity. So this week we will learn about the factors that affect the enzyme activities and also more details on the cofactor and also inhibitor of the enzyme. So there are several factors that affect the enzyme activity. The first one is pH, second one is temperature, enzyme concentration, substrate concentration, the presence of inhibitor, and also the presence of cofactor. So the first one, pH. So pH, okay, can influence the charges, the hydrogen bonding, and also the ionic bonding within the enzyme. Okay, so therefore, any changes or disruption in bonding will affect the shape of the enzyme active site. Remember, active site is the part of the enzyme that will bind with the substrate, okay, or the ligand. And if the shape of the active site is being disrupted, it can cause the denaturation of the enzyme because enzyme is a protein. So any changes in charge of the active site will affect its binding with the substrate. Next is the temperature. Okay, before that, all enzymes have their own optimum pH, where at that pH they will work very optimal. Okay, same with temperature also. All enzymes have their own optimum temperature. Okay, so below the optimum temperature, the temperature will increase the kinetic energy of between the substrate and also the enzyme, where they will collide more often. The enzyme and the substrate will collide more often, thus increase the rate of reaction until the maximum rate of the optimum temperature, as you can see over here. And above the optimum temperature, for example, is that for typical human enzyme is 37. So above 37, what will happen? The temperature is of course increased. Thus, the molecule inside the enzyme will vibrate very frequently and they will break the bond which hold the molecules in their precise shape. And then the enzyme become denatured. The substrate cannot bind to the active site of the enzyme, and of course the enzyme will lose its catalytic properties. Next is enzyme concentration. So of course, the higher the enzyme concentration, the higher will be the rate of reaction, because you have a lot of active site to convert the substrate into the product. Okay, that's why its graph is proportionally increase. Okay, so when the temperature and pH of that reaction is kept constant and the substrate concentration is higher or sufficient, then the rate of reaction is proportional with the rate of the enzyme concentration. The higher the enzyme concentration, the higher will be the rate of reaction depending on the substrate concentration. Okay. Next is substrate concentration. So substrate concentration also can affect the enzyme activity. So the rate of reaction will increase with the increasing substrate concentration. Okay, and however, further increase of substrate will produce no significant change in reaction rate of reaction. So why? Let's look more detail on the effect of substrate concentration on enzyme activity. So look at the first phase here, A phase. So we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 enzymes, therefore 8 free active site that can bind with the substrate. So at the early stage of the reaction, okay, there will be a low amount or number of substrate that will bind with the enzyme, active site of the enzyme, thus cause the low reaction rate. Okay, but then, however, by time, okay, by time and when the substrate concentration is increased, of course, they will fill all of the active site, free active site of the enzyme, and therefore the rate of reaction will increase. And okay, however, at phase C here, okay, at stage C, when you add more substrate, okay, unfortunately, there is no available free active site to bind with the substrate. That's why the graph will be constant, okay, because only 7 substrate can bind with the 7 active sites of the enzyme, okay, and the other substrate, okay, will have to wait their turn, okay, after the other substrate already converted into the product. Next is inhibitor. So what is inhibitor? Inhibitor is a reactant, is a ligand, not the substrate, of course, that can reduce or stop the catalytic activity of the enzyme. And we have two types of inhibitor. The first one is reversible inhibitor, and the second one is irreversible inhibitor. So I will explain more further on this one later. However, what you have to know about reversible inhibition is that irreversible inhibition is happen where the inhibitor it bind to either the active site or the enzyme or the allosteric site of the enzyme by weak interaction or weak bonding. So meaning to say the inhibitor can detach from the enzyme, so they only reduce the enzyme catalytic activity. Okay, different with irreversible inhibition. Irreversible inhibition is an inhibition where the inhibitor will bind to the active site of the enzyme so that the substrate cannot bind with the enzyme, and the binding between the inhibitor, irreversible inhibitor, with the enzyme is by strong bond. Okay, when they are held together by a strong bond, the ligand or the inhibitor cannot detach from the enzyme, thus causing the enzyme to denature and of course stop the catalytic activity. Okay, and last thing that affect the enzyme activity is cofactor. Enzyme is a protein, okay? However, cofactor is a non-protein component that will bound or bind to the enzyme either tightly by strong bond or loosely by weak bond. Okay, so enzyme cofactor is we call as a helper for the enzyme because some enzyme required cofactor for their activity efficiency. So we have three types of cofactor: inorganic cofactor, prosthetic group, and also coenzyme. So let's look more details on cofactor after this. However, look at this one first. Enzyme without any cofactor, we call it as apoenzyme. Okay, apoenzyme. Okay, when the enzyme combine with the cofactor, okay, to help or to increase the enzyme efficiency, this enzyme now we call it as a haloenzyme. Okay, enzyme without cofactor is apoenzyme. Enzyme with cofactor is haloenzyme. Okay, so more details on cofactor. Cofactor, as I mentioned earlier, is the non-protein component that required to increase the efficiency of the enzyme activity to help for the enzyme to proper functioning. And cofactor can bound very tight to the enzyme, so permanently bound, or they can bind loosely with the enzyme by weak bond. Okay, and however, even though the cofactor attach or bind with the enzyme will still unchanged at the end of the reaction. Okay, they will nothing will change the enzyme before and after the reaction. And three types of cofactor, as I mentioned earlier, inorganic ions, prosthetic group, and also coenzyme. The first one is inorganic ion. Inorganic ion, also known as enzyme activator. The function is that they will shape up the enzyme, or they can shape up the substrate into the shape that can cause the enzyme and substrate complex to be produced. This one can refer to the enzyme mode of action, which is induced feed theory, where in the induced feed theory, the active site of the enzyme will change into the shape of the substrate. Okay, therefore it can increase the rate of reaction that are catalyzed by specific enzyme. Examples of inorganic ions are potassium ions, sodium ions, and copper ions. Okay, here, so as you can see over here, the shape of the active site of the enzyme is not exactly the same with the shape of the substrate. So what will happen if here what will happen is that the inorganic ion will bind to the active site of the enzyme. Thus, it will help to shape the enzyme to resemble the shape of the active site, to resemble the shapes of the substrate. Next is prosthetic group. Prosthetic group is referred to an organic non-protein substances that tightly bound to the enzyme, and it is the active part of the enzyme molecules in which its function is to take up chemical group from protein parts of the enzyme. Example is enzyme cytochrome oxidase that play roles in respiration, and they have a prosthetic group hem that contain the ion. And last but not least is that the last cofactor is coenzyme. Coenzyme also organic molecule, organic non-protein molecule, similar with prosthetic group, and they bind with the enzyme, of course, same with the prosthetic group, which is by this one. Okay. However, the difference between prosthetic group and coenzyme is that prosthetic, they bind very tightly with the enzyme. Meanwhile, coenzyme do not bind tightly with the enzyme, and they do not remain attached to the enzyme compared with prosthetic group. Okay, so most of the coenzyme is classified as transfer agent because they can help to transfer some component from one molecule to another. Example of coenzyme are NADH, NADPH, and FADH2, in which you will know about this later. You will learn about this later on aerobic respiration and photosynthesis chapter. Okay, I think that's all for today, class. Thank you.